Let's start. Good afternoon, everyone. Here we are for the knowledge session, and today's agenda would be functional programming. But first, start with the knowledge etiquettes. Punctuality. Join the session 5 minutes prior to the session start time. We start on time and conclude on time. Feedbacks. Make sure to submit a constructive feedback for all the sessions as it is very helpful for the presenter. Silent mode. Keep your mobile devices in silent mode and feel free to move out of session in case you need to attend an urgent calls. Avoid disturbances, avoid unwanted chit chats during the session. Here is our agenda, what we are going to do in our next 45 minutes for the functional programming. First, we'll discuss a little bit introduction. Section 2 will come up with programming paradigms with imperative programmings and declarative ones. Section 3 would have the functional programming principles with first-class functions, pure functions, higher-order function, and immutability. Section 4 will have the functional programming versus OOPS, the comparison, and which one is better. Section 5, we will wrap up the whole session and with a conclusion. So let's start. What is basically a functional programming? So basically, it is a programming styles and that treats the computation and evaluation as mathematical functions, and it changes the is changing state and mutable data. What is mutable data and how it helps in immutability? We will always discuss in our upcoming slides. And this is based on lambda calculus, and there are some inputs given to it, and without any modifications, we get the outputs. There is no iterations, no loops, and no variables. So when we talk about the no iteration, the first thing that comes to in our mind is that how it is possible that without the loops, without the iterations, how could we do that? So it seems a little bit impossible, but it is possible. Let's see with a quick example here. This is a very simple example that we are having array of numbers, and we are iterating to its length, and we are getting a multiple of 2. So when you see the left hand side, we are getting the output, but we are using for loop here. And as I said that we don't need an iteration. In the right side, you can see that we are using a map, and we are we are getting the same output, but without the iterations. So this is basically what we are trying to say, that it is possible to get the conclusions without iterations as well. Now we are coming towards the programming paradigms. The first one is we are going to discuss is about the imperative programming. So basically, the imperative programming is mainly focuses on the sequence of instructions. Means what we are doing, we give that, and but how we are doing that, we also try to wrap that, and we also try to give to the system that how we are going to conclude that step by step. And there is a detailed instructions to manipulate the program, specifically exactly how tasks should be done. So here there are variables, there are loops, and there are routines to modify and update the programs. So the execution, as I already said, that there is a step-by-step of executions, and the whole logic and whole order of instructions are also written over here. If we give a normal programming languages that are using the imperative styles, then they are C, Pascal, Python, which are widely using the imperative programming style of code. So as we have given a small definition of what imperative programming actually is, we can have a key points as well that will certainly come up through that what imperative programming actually is. So it is a sequential execution. What I meant here is there is a sequential execution, means there are instructions written over there that how we are doing that, and each and every instructions would be executed one after the another. That's why the imperative has a sequential execution. The second would be the mutable state. Means these variables that we are storing, whatever the data we are having here, this will update data, and we are able to manipulate the data as well. Third one would be the control structures. Means in our programming languages, we are using the statements one after another, that if else statements or whatever the control over the instructions we are having, that how part we are doing, and that is always in our control. what is we are going to execute, we have given that, but how we are going to do that is in our control only, that how the flow of the execution would be. The fourth one would be the procedural abstraction. So imperative programming basically encourages the use of procedures and programs that encapsulates the reusable blocks of code. Means that there is a promote of code organization, and we can reuse that as well. So there is a procedural abstraction. The instructions that we have provided, they are always in the procedural form and they are always abstracted. Direct manipulation here, it emphasizes basically on that the variables that we are using are always in a direct manipulation variable state, memory and program states as well. Since it has all the instructions that how we are going to implement it, the imperative style of coding is a bit complex and it is a bit difficult to understand. Means if I have written the code and someone else wants to see what I have written, so it would be a bit difficult for other programmer to understand it, because it is more complex. Every instruction that how part is always given over here. So if okay, so let's have a quick example of imperative programming here. That we have given a array, and there are certain numbers over here, and we are using a for loop and towards the length, and we are iterating it one by one, and we are having a sum of numbers. So we have always given a certain procedures that how we are going to implement it. It's a very simple example that using a imperative programming of code. So is there any questions on imperative? We can move towards the declarative one then. Okay. So the next one would be declarative programming. So it basically that we have seen in the imperative style that we have given the what part and the how part as well. But in the declarative programming, it basically describes the outcomes only. It basically have the interest in outcomes only, and does not, we do not need to give the whole instructions step by step procedures in the declarative code of style. So it basically have the relies on the expressing relationships and constraints and problems and tasks, and it always abstracts the control flow. Means you don't need to tell the system that how you are going to implement these instructions. You just give the system some inputs, and you want that you these certain outputs. You don't need to give one by one instruction to that system would handle, the tool will handle by its own. So the very quick example would be the SQL database. If you have gone through the SQL queries, then if, for example, if I say that there is a table and you want to query a certain amount of data from it, that you want a people name, column name, then you just give a query to it, select star from this table. Just you give an input that you want this, but you are not giving the whole instructions that how it would be retrieved and how it would be fetched from the database. You are just giving a query, simple query. So that's why it's called a declarative programming, that you are just mainly concerned on the what part and how it would be done. It would be all in the tool's hand, not your own hands. It would not be in your control, basically. So the other thing is the declarative programming separates behavior concerns from implementing details. Implementing details is that how we are going to implement it, right? That how the instructions would be done one after another. You are not concerned, really not concerned about how it is going to do that. You are just basically concerned about the output, that you will get the concerned output. It enables easier reasoning about complex systems. So basically, when we read about the imperative in our previous slides, then we gone through that there would be complex structure, because in each step we are providing the instructions one after another. So there would be a heavy code, much code, and complexity would be much higher. In the declarative, we are just concerned about the what part and not about the whole instructions one after another. So that's why this is less complex. Okay, so after the certain definition, we can have some key points from the declaratives that focus on what, not how part. So as we have already discussed, the instructions that we have to give in the imperatives ones, we don't have to give in the declarative ones. We are just concerned about the what part and not the how part. Declarative languages and tools. So basically the tools that we are going to do that, it's not always that we will provide any tool, we will use any tool and just give the what part and the system will handle it. No, it would require some tools that are handling these kind of things. Like for example, as I've already told, as SQL, Prolong, these things are having such kind of tools which will handle by the system that how the things would be going through. So basically in the declarative ones, we always need a tool for that. And declarative constraints and rules. So the basic rule would be this only, that the describe the problem to me and not how the rules would be there, that how the instructions would be going through. So underlying the system automatically derive a solution to compute the desired result. The system would always handle it. You are not going to tell that what how this be done, and it will mainly focus on the relationships of the problem. You will just give a problem statements and the system will give the whole relationship of the problem and procedural steps to achieve the required results. And separation of concerns. So the basically the concerns would be that what part and how part. So it would separate all the concerns about this, that modelizing and abstracting the logic, the whole logic would be encapsulated, that how you are using it. So that's why that the code would be reusable and modularity, and declarative programs tend to compose of smaller reusable components of modules, that these all programs would be in such a small format in small modules that you can reuse them whenever you want to. And you can always there is a always a point of combination of functions when we use the declarative ones. So we can always combine those small modules and have it in different ways to get the outcomes and results. Higher order abstractions, we would see the higher order functions as well in our upcoming slides, but here we are seeing about the higher level abstractions, because the instructions that we are going to give in the declarative style, we are not concerned about that. So always the whole procedures would not be impacted in the code, and we would not be able to read it. So this is simplified version, and that's why the simplicity of the whole code would be there, and there would be no complex concepts on it. So there is a quick example of the same thing. This is the same example which we did in the imperatives style with the for loops. So here we are using filters, map, and certainly we are having a sum of all the array list. So this is a declarative style in which we are not using for loops, and look how the code clean it is looking as compared to the declaratives ones. So this is a basically a quick comparison between what we have read in previous slides about the declarative and imperative ones. That declarative ones always transforms and always just concern about the what part and not the how part. But in the imperative ones, we have the step by step many changes, and declarative ones describe what you want and end result. You just are concerned about the end result only. You don't need to give the procedures every time. But in the imperative one, you need to tell the computer what to do and how to do. So then the declarative function calls would be there with the help of recursion, and imperative ones there would be loops, iterations, conditions, functions, method calls, etc. And the declarative ones there would be a first class object and data collection. We are going to discuss more in a deeper way of what the first class objects actually are. And in imperative ones, we are using the class and structures. So the example, if we say the SQL would be the declarative example, Haskell, Erlang, and imperative ones, the Fortran, assembly languages, couple would be the imperative examples. Now, if we want to give a quick example for the live example, what is the major difference between the imperative and declarative one? I just want to give a quick example on that. So if we want to go towards a airport, and we are currently from our current location, so there would be two cases. First case would be that just you say that from a current location I just want to go towards the airport. where you are just giving over the destination that you want to go towards the airport. You are not giving anything else, how you will reach there, nothing else, just a correct destination. So this would be a declarative example. And on the other hand, if you are giving the whole instruction that from your current location, go towards your right, go towards your left, all the step-by-step instructions are given, then it would be an imperative example. So it's just a real life example that through which we can get a major difference between both of these. So that's a quick diagram which can be shown to differentiate between the imperative, declarative, and functional programming, which is the basic topic for us. That imperative is tell what and tell how. You would be much familiar with this terms now, but till these slides, that what we are trying to say, that imperative has what and tell how. In the declarative, tell what and not how. Don't need to give the whole instructions. And then the functional is basically, functional programming is basically under the declarative only, declarative plus higher order functions. So in our upcoming slides, we are going to discuss in a much deeper way about higher order functions. But till now, you can understand it that functional language is a declarative style with the higher order functions. So if there are any questions till now, we can take that. Otherwise, we can move forward. Okay. So the next would be foundation and principles of functional programming. So first we would discuss about the pure functions, what are the pure functions, and how it is related to our functional programming things. So pure functions would be those that lives independently. Independently as in they don't need object, instances, class, scope to execute. And they does not depend on the external values as well. And the output of a function is always a value and does not change its argument value, means it is immutable, means does not change an argument value or any other external value if they are using. And function may returns other functions as output as well in this. And if we can take a reference of oops methods returns oops methods only, that in oops we see that it returns only one value, and that must be an object instance. But if we are talking about the functional programming, then it may returns function and it can processes that also. So there is a small very little bit difference between the oops and functional programming. Here we can see that the in oops we are returning a value only, but but in a functional programming, we can return a function and process it as well. So the next point would be the function would be composed together. So here we can say there is a chaining of operation. We in upcoming slides we will talk about the chaining of operations or chaining of functions also, that we how we are going to do that. That it small and small functions could be changed together and could be combined together to get a better result, to a more outcome results. So these functions could be composed together. This is called a chaining of functions. So let's have a quick example over this. Like in simple pure functions have always the first thing to keep in mind is that if we are using the pure functions, then with certain amounts of parameters, certain amounts of inputs, we will always get the same outputs. Always we will get the same outputs if we are using the same inputs. Then it does not rely on the change anything outside itself. It only uses the input values and calculate the results. So here is a quick example over that we have used a variable and initialize it with 10, and we are calculating a test with all the procedures. So let me give you a brief description that here in this example there is nothing wrong. We can use that, but this function is not a pure function. Why? Because in our previous slides and this one also we have turned that in pure function we don't use the external variables, and here we can see that the text is an external variable that we are using. So now we can see that how can we use that in a pure function style. So here in this procedure we have removed that external variable. Now it is a pure function. We can do that in other many ways as well, but here is a small example that how can we do that. Now if this is a pure function and it will always produce the same result, rather than if we execute it one time 10,000 times or many other times, from the same inputs, it would always give the same amount of result. So this is basically the pure function, what it tells about. So as we have read about the pure function definitions, a quick example, and how can we make a small function towards a pure function conversion, then we can have a quick benefits of pure functions as well, that why we want the pure functions if we are using normal functions also. So basically the predictability and reliability. When we are saying the predictability, then as I said that with the same number of inputs, same arguments, we are always having the same outputs. So the testing and debugging would be very easy on this, because we know that yeah, this is reliable, this is always predictable, that with these amount of inputs we are having that outputs only. Avoidance of side effects. There would be no side effects on it, because we are modifying it and there is no external state of variables. If you are somewhat familiar with the operating systems terms with deadlocks and all, then you could clarify these second point in a much better way. You can understand it in much better way, that how the external variables that we are using can lead to deadlocks and all. So there would not be unexpected changes if we are using a shared state. So as pure functions are not using any external values. Third benefit would be reusability and modularity. Since these pure functions are self-dependent and they don't need any other external states to rely on, they have everything on its own. So we can reuse it whenever we need, and there are no different contexts, and there are no unexpected iterations, interactions as well. So we can use them safely whenever we want to, as they all are self-dependent and have everything in their own only. So next point would be facilitation of parallel and concrete execution. So as I said that if you know OS, then it would be much easier way to think about the concurrency execution and all. So since there are no side effects and we are not using any external or shared state, we have not used that. We are implied on our own states and own variables. So there would be no shared values, and we would not be rely on any other things. So that's why the concurrent execution would be very good in pure functions style. And optimizations, because pure functions always have the same output with the current amount of inputs, then it means that the whole thing could be cached and can be stored as that performance improvements as well, because avoiding unnecessary calculations. If we are having the same inputs again and again, and we are having the same conditions and calculations on the same inputs, then why we would try give the same instructions again and again. So we can use a pure functions and have the cache of all the inputs as well, that with these amount of inputs we will get the required results. So this is about the pure functions, and we can have a quick thing that functional programming as a pure function, that how can we say that the functional programmings are the pure functions. So as we have read till now, that function exists independently. There is no bound on objects or classes. There is no change of state of object, and make means it does not change the object or value. It just make a cookie from that and modify it and then return it, but they do not change the actual value. That's why we are saying that yes, this is a pure function, and all values are immutable, that you are not changing the actual values, you are just making a cookie out of it. You are just returning it and just modifying it, that cookie that you have made, but you are not actually modifying or updating the actual values. So the next would be no iterations, no operations are done only with the help of recursions. No iterations are there, for loops, while loops, nothing is there. The whole thing would be on the recursions only, and we are not using counters as well here. So yes, we can say that they are using a pure function style of language. Now we can have a quick walkthrough on the first class functions that we have seen in the previous slides. So we can deep dive in that what basically are the first class functions. So the main three key points would be that it can have we can pass the functions as an argument. if you see that assignability, in case of assignability, that as we assign values, then we can assign the functions as well in the same way. There would be no change. Possibility that if just like any other arguments or the functions, we are able to facilitate the creation of higher functions, where functions can accept the functions as well. It's not always that we have to provide the values. We can pass a function inside a function as well. Returnability, the function could return a function as a result, as values from, like we use the values from other functions. This capability of functions to generate the deliver new functions also, that we are using a function and we are returning a functions also, and after that we are getting a result. So there is a chain of functions always. So that's why we call it as first class functions. Encapsulation, why this is having an encapsulation, basically because the whole code and the state in the first class functions is encapsulated, and there is would not be a variables from enclosing scope, and outer function has completed execution over that. So first class function also have a higher function support, that whatever the requirements are, that the as the higher functions we can say, because it is accepting functions as an argument and returning that as an argument, and procedures are also performing in the function just itself. And the very in the very beginning I also told about the chaining of functions. So in higher functions we are combining small functions as well and composed to create a complex behavior and algos. So we can say that yes, HOFs are also a first class functions examples. So for higher order functions, as we have already gone through, that they are taking parameters as functions, returning as functions, or both, and and performing the functions in itself as well. So that's why it's called the function composition. We can wholly perform that always the function inside the function only. And in the higher order functions, it treats functions as values only, that if we are manipulating the data types or anything else, then we can do that with the functions only, no need to have the values itself. And they can also return a function as the result, as we have seen that it has taken as a parameter as an argument as a function, and it has returns other functions as well. So they are either accepting them as parameters or producing them as output, and always they can do both as well. Working with functions as data enables powerful abstractions, and they could the code reusable would be there. And the expressive paradigms like functional programming. Functional programming also allows the HOFs, as we have already seen in that diagram that I have shown in the second, third slide, that the functional programming is basically the declarative one plus the higher order functions. So we have to keep that in mind, that if we are using a functional programming, then we can use that HOFs as well. So the prominent features that in the HOFs that programming languages are using, we can take an example of JavaScript. We are using an HOFs. So this is a quick example of that, what we are trying to say over the HOFs, that if we want to filter out the spaces that we have used streams here, and we have to filter out that starts with G and which should be 4 letter long, and we are using a for each. So now as I have told, would be a composition of functions. We can use number of functions, and we can combine them all together to get a required result. So we can see from previous example only that here we are using the stream, we are using filter, we are using sorted limits and for each things, and we are having so many functions and combining all them together to get a required result. So just take an example that you are doing the same type of code in imperative style with for loops, and like in sorted thing only. If you are using a sorted thing, then in imperative you have to write a full code and full instructions that how you are going to sort it. But if you are using this HOFs technologies, and you are having that inputs and the next functions forming a chain of functions, and you are just giving a sorted, and yes, it would be done. You are not going to give that whole instruction that how it should sort or how it should do. So so basically the whole thing would be this, that in we could perform many functions, and we could chain them together, and we can get the outputs. And this would be a sequential applying of functions, means one after the another, always, that first it would filter out, then it will get sorted. It would be a sequential applying of every functions. Then sequential, as we have said sequential, then it would be very much understood that the output of the previous function is the input of the other function. That's why we are calling it a sequential. And you can see that we are doing so much instructions over here, but still it's more clear, concise, and usable expression of computations. And this is basically a fundamental concept of functional programming is. And there is a powerful abstractions and transformations over here. You can this is a very simple example, but you can see that how the abstractions is done. You don't need to tell them how you are filtering it, how you are sorting it, how you are doing every transformation and instructions are just in abstracted form. Code becomes smaller, specialized functions can be changed together to achieve the desired result. So basically, the most important thing here, we can see that if someone is writing a program, and any other programmer wants to know that what they have done, so this would be a very quick walkthrough that what the code is trying to say, and in a much clear and concise way eventually. So benefits of HOFs, that it has a code reusability. There are higher order functions. Code reusable is also allowed here, that arguments that we are providing and returns our values itself, then we can use that code eventually anytime. And abstractions is there, as I've already seen that in the previous example only, that how much the code is abstracted. You are doing things, but you are not writing the whole procedures, and you are getting the results as well. So that's why we are saying that abstractions and expressiveness is very high here. And a separation of major concerns, that how the separation of organization, readability, and how they are maintaining all these kind of stuff, these all concerns are separated from other things. Functional compositions, that we have already seen here, that in higher order functions we are making use of so many functions one after the another sequence in a sequential procedures, but these all functions are combined together, and we are getting an enhancements and reusable results as at the same points. So, a functional programming paradigms is basically the higher order functions, and as a fundamental tool in much concise and declarative programming style. We are using maps, filters, and reduce. So, whatever we it needs to be done rather than how it should be done. We are just concerned over here only, that from if you can correlate that from our first slides, we are just trying to say that what we are doing and how we are doing. And now in functional programming, we are just seeing that using the HOFs, if we relate both these things, that in HOFs also we are just concerned about what we are doing and how we are doing instructions. We don't need to tell them. So this is a very quick thing that you can correlate with our previous slides as well, that functional program paradigms are using the higher order functions. They are declarative ones with the HOFs. Okay, now, so is there any question on these slides? You can take that up quickly. Okay, I'll take that as a no. Okay, why not mutability? So from very beginning, we are trying to say that no mutability, no, please, no mutability. So why not? Because if we are using that multi-threadings and multi-cores of CPU, then you can see that we want to make use of instructions parallelly. And in multi-core, data is keeping the object state as it is very difficult, is the hardest part, you can say. And dealing with the common, as you are dealing with the common data, and you are executing the instructions parallelly, and you are dealing with the common data, shared data, then it would be very hard to keep the state of the execution, keep the external variable or state the same as it is. It would be very difficult, and which is the main reason of the bugs of the concurrent applications. you can say maybe it would be a deadlock, or the state would be changed though, so you are getting different instructions for different outputs, so it would be a very hazards. So that's why we are trying to synchronize the common data. That's why we don't want mutability in our slides. So immutability. So basically, as we know that our functional programming is immutable. So there are immutable variables, and all the entities are treated as immutable. And state preservation, as we said, that if we are using concurrent programming, that the state preservation would be there, no side effects would be there, as the values could not be changed and part of the program. This property make it easier to behave. And functional updates, that we are using a functional programming as so often that it is not modifying the original values. We are just keeping it and updating it in our functions, but we are not updating the actual values over there. And reference transparency, whatever the reference we are taking, the whole function program is transparent about this. So it is immutable. Thread safety, why we are saying that it is thread safety, because the it cannot be modified, the thread in which we are using the external values. There would be multiple threads, but yet it would be safe. Code clarity and maintainability, the whole code, the values do not change. That's why the flow of the whole data and behavior of the functions becomes more evident, and the code clarity would be there. Reusable and sharing of the data, as there would be an immutable values and safety of reuse across the different parts, and it is not affecting the actual line of state of the values. So we can say that yes, this is reusable and sharing, and immutability is there. And now the basic thing that we have seen, that all the functional programming things, that what it is, how it is, and what they are doing with the functional programming. Now, a quick question, that is it Java 8 giving the solutions for functional programming? So not much, but we have given a 3 points over here, whatever we have read previously, that it is immutable state, and Java 8 is giving a solution of it, that yes, it is maintaining the immutable state with the final keyword. And declarative, not imperative attribute. Javed is giving a solution of streams, that through streams, as we have seen in the previous examples also, that with streams we have made that code from imperative to the declarative ones. So yes, we are using streams in Java, so we can say that yes, it is a solution for the functional programming. So no iteration, only recursion. Again, we are not using for loops here. There is no iteration over here. We are just using the recursions examples. So we are using streams in Java solution. So we can say we are using the functional programming paradigms over Java, and Java providing somewhat solutions for the functional programming styles. So now we have come over the functional programming versus OOPS. That whatever we are using in OOPS is it better, or is it much better, or how they could be compared. So the first point would be the order of execution isn't always important. It can be in asynchronous in functional programming, that we don't need that the order of functions would be very much important for that. But in OOPS, if we have used OOPS, then execution of statement sequence is much important and much crucial. The second point would be the function of basic building elements, and in the OOPS, as the name suggests, the objects are the basic things and main abstractions of the data modeling. And in the functional, it would be a declarative paradigms, and in OOPS, it would be imperative paradigms. As we can see that in the imperative styles, we are more concerned about the sequence and instructions that we have given, and in declarative we are not concerned about that. So as in the previous slides, I have already given the difference between the declarative and imperative. So from that you can go through that. Okay, there's a major difference between OOP and functional programming that we are using. So in functional programming, it mainly focuses on the results and the final results only, and don't no conditions, final conditions only, and no bit in between things. And in OOPS also, it focuses on the desired result, how the desired results could be achieved, not only the what part, but also the how part. And in functional programming, it ensures the immutability. Program should be stateless. And in OOPS also, the state changes are important part of the execution. So in functional, the primary activity is writing new functions, and in OOPS there is a building block, composition, and extending of the objects, as we have already seen in the OOPS concepts that it is all about the objects, extending the objects, composing it, and building it. So this is a major difference between these things. And what it's not always that always the oops is right, or always the function programming is right. It is always up to your code, quality of code, and what you actually want to have. So these are the major differences, and you can decide what you want to choose as part of your code requirements at that time. So now we are coming towards the conclusions. As we have seen all the functional styles and what the functional paradigms are, and whatever the things are, now we can have the functional style benefits, that why we should use, or at what state we can use the functional styles. So basically, if I'm just taking an example of Java 8 only here, that functional styles that are introduced in Java 8. So there it reduces the gap between the business logic and the code. So it is basically the same thing, that it gives a natural flow over the higher order style, that you don't need to be much concerned about the whole details and whole instructions that you are going to do, but it is more about that how what you want to do. You can say what you want to do, want to be done, just give it it is a statement and it would be done. So Java 8 is providing you that much of a solution to you, that I have given the in the previous slides, that we are using streams, attributes, the quick comparison over that, or not all the things, but yes, most of the things you can use in the Java 8 solutions. So the next would be the cleaner and more concise codes, as you are using the giving the instructions, and there is no use of much variables over there. So invariant variables would not be required, and thus you can make use of functional styles with a more cleaner and concise codes, and it would be easier to reuse, focused, and robust in nature. And very thanks to lambdas over here. If you have used Java 8 lambdas, then it would be a great thing that we are using it here, that it is now we can now do lazy evaluations, lazy evaluations, as in that no executions would be done until and unless we want it. It would be always dependent on the other statements. So when sending a lambda expressions, there is a method argument in the Java compiler is using it to evaluate the methods. And testing would be the best thing that functional styles are giving to us. That it is so clean and small and quick, that we are just giving the unit test cases and just testing it whenever we want to do that in a much quicker way. So yes, this is a quick thing that we have used in the function styles. If there are any questions, we can take that up, but here we have concluded over the function styles and why we can use that. So if there are any questions, we can take that, or unless you can always reach out to me if in person as well.
Hi, Shraddha. This was a very, very disruptive session by you. Guys, if you're having any session or if you're having any question, you can please reach out to Shraddha later on. As we have to join the another session as of now, so I'll just ask you to please wrap the session over here.